doing experiments of this nature. So now let's imagine you have an artificial chromosome. This is a made up story. You have a chromosome and you have different genes on it. You have a gene here that converts the body to yellow when it's mutated. You have a gene here which, when mutated, gives you white eyes. Hypothetical organism. You have a gene here where you have no bristles on the body. You have a gene here which gives you fork bristles when you mutate. And then you have a gene here that also gives you white eyes. Except you are a researcher in Spain. And you are calling this eye blanco eyes, right? So, you might have two genes that are giving you the same phenotype. You need, as a researcher, to know if those two genes, those two mutations that give you the same phenotype, isolated in two totally different labs, say one in the US, one in Spain, or wherever, are they mutations in the same gene or different genes? It's the experiment that was done by Beadle and Caden, but in multicellular organisms. You can't basically feed flies a certain pigment and ask if you can convert them, etc. Even if you know the entire pathway for pigment production, you can't feed them those intermediates and expect the eye color to change. So how do we go about figuring out when you have mutations in two individual flies with the same phenotype, whether that is mutations in the same gene or different genes? That's the question. And that's where we go with genetic complementation. So, you are familiar with the fact that if you have a single gene, like this one,